Welcome to today's Explainer. We're diving right into a seriously fascinating, kind of unorthodox theory about something you literally see every single day. We're breaking down an alternative macromechanical theory of water surface tension. It's all based on a really specific source text called Theory of Water Surface Tension, Gravity and Air Pressure. So instead of squinting through a microscope at tiny molecules, the author actually wants us to zoom way, way out. We're talking about looking at this whole phenomenon strictly through the lens of macrophysics. So what if water surface tension isn't caused by molecules at all, but by gravity? Think about that for a second. It's a pretty wild thought experiment, right? The text invites us to just temporarily step entirely outside the standard scientific consensus. It's asking us to put everything we learned in high school chemistry on pause for a minute and entertain this purely mechanical, gravity-driven universe that the author lays out. Section 1, the molecular theory versus the macroscopic view. Let's look at this new perspective. Right off the bat, the author's text draws a massive line in the sand, contrasting its own ideas directly with standard scientific explanations. Now, you know the standard view, right? It relies entirely on molecular cohesion, the idea that water molecules are magnetically attracted to one another. But this source theory, it argues something completely different. It says that surface tension is actually the result of macro-level forces. Specifically, we're talking about gravity and air pressure acting together inside closed spaces. Now, we're just here to neutrally explore the stance today, but it is really interesting to see exactly how the author builds this macroscopic argument step by step, completely ignoring molecular bonds. Section 2, Gravity and Enclosed Spaces. Let's talk about the role of the container. What's truly fascinating here is the sheer scale the author uses to make this point. According to the text, the absolute fundamental requirement for surface tension to exist is that a liquid has to fill a closed gap or space. Okay, so that could be something super small and familiar, like a normal glass of water sitting right there on your kitchen table, or a puddle in a natural hole in the ground. But then, scaling up massively, it also applies to entire oceans, filling the vast spaces between continents. In fact, the author explicitly points out that this exact principle, filling a closed gap, is the reason why oceans have depth between our land masses. Basically, the container itself is absolutely crucial to everything that follows in this theory. So here is the step-by-step mechanical process the author lays out for us. It goes like this. Step 1, the water fills that closed gap we were just talking about. Step 2, gravity acts on this enclosed liquid, actively pulling the water straight downward. Step 3, because the water is trapped in that container and being yanked down, it gets compressed. And finally, step 4, it's that very compression that actually generates the surface tension on top. It's a purely mechanical sequence from start to finish. This crucial point is summed up perfectly in this quote, translated directly from the original German source. That is what compresses the water, not pulls it together. You see, the author is making a really sharp, very deliberate distinction here. The force at play isn't some lateral molecular attraction pulling the surface together into a tight little sheet. Rather, it is the downward pull of gravity, physically squishing and compressing the water down into its container that creates the tension on the surface. Okay, section 3. The lunar thought experiment, testing this out in zero gravity. To really test this gravity-based theory out, the author throws us into this totally wild spatial thought experiment. We need to see how these mechanics hold up under wildly different physical conditions. And the author makes a super direct assertion right here. Surface tension simply cannot exist in a zero-gravity environment. Think about the logic of the text. If you're floating around in a completely weightless room, a space with absolutely zero gravity pulling downward, well, the compression you need to form surface tension just isn't there. So consequently, this specific type of macro-mechanical surface tension just cannot form at all, period. But wait, the author applies this incredibly fascinating nuance to the rule when we look at the moon. According to the theory, surface tension actually can exist on the moon provided the water is inside a container, something like a huge lunar crater, or even just a simple glass. Because, even though lunar gravity is way, way weaker than Earth's, it is still gravity. So as long as you've got that closed gap and a downward pull compressing the liquid, the author states that surface tension is going to successfully form. Moving on to section 4, the influence of air pressure, or the weight of the atmosphere. Now, this next point vividly illustrates the sheer mind-boggling weight we're actually talking about here, 10 tons. The author specifically uses this 10-ton figure to help us visualize this massive, invisible, heavy blanket of atmospheric pressure that is constantly pushing down on the water. We're not talking about some subtle, gentle influence here. It's literally roughly 10 tons of air pressure bearing down on the surface. So, When we put it all together, you can really clearly see these dual forces at play, at least according to the text. Just picture it. You have the water sitting in its closed space, you've got gravity firmly pulling it from below, and then at the exact same time, you've got those 10 tons of atmospheric pressure just crushing down from above. The water is effectively getting squeezed, just completely compressed, right between these two massive macro forces. And to push this logic all the way to its absolute extreme, the author shares this incredibly vivid imagery. If you were at 100 bar pressure, the water's surface would literally have to be rock hard, or steinhart, as it says in the original German. By drastically cranking up the atmospheric pressure to 100 bar, which is roughly 100 times the normal pressure we feel walking around on Earth, that downward force becomes so unimaginably intense. Following the author's theory logically, the physical state of the water's surface tension would actually alter to become as hard as stone. Crazy, right? It's a super striking way to really drive home the role of atmospheric pressure. Finally, Section 5, the conclusion, macroscopic surface tension. So here is the author's ultimate conclusion, delivered exactly as it's laid out in the text. Water surface tension is simply defined as a product of gravity and a closed space, which is then heavily reinforced by air pressure. And honestly, that's the entire alternative mechanic right there in a nutshell. No tiny molecular bonds, no microscopic cohesion, just the undeniable, heavy physical reality of gravity pulling liquid down into a container, completely aided by the crushing weight of the atmosphere right above it. I want to leave you all with one final, really expansive thought to chew on. If gravity and atmospheric pressure are the true sculptors of a water's surface, how completely differently does liquid behave across the vast reaches of the entire universe? Just imagine planets with totally crushing atmospheres, or strange moons with barely even a whisper of gravity. How would a simple glass of water actually look sitting on a table out there? It's a super provocative question inspired by a very, very unique perspective. And for sure, it kind of completely changes the way you look at a simple drop of water. Anyway, thanks so much for joining me on this explainer, and hey, keep questioning the mechanics of the world around you.